Hello. Welcome to the series on e-learning module in statistics and statistical methods. In this module, we are going to cover a basic yet important concept, frequency distribution. Frequency distribution forms the basis of many statistical analysis methods. Our objective in today's session is to understand the concept of frequency distribution and how useful it can be in our life. By the end of this session, you will be able to understand and appreciate the following concepts. What is frequency distribution? The need for frequency distribution in statistical analysis, steps involved in preparing a frequency distribution table, uses of frequency distribution. Statistical analysis involves not just numbers or graphs, but also facilitates the process of simplifying data or numerical expressions to arrive at the final conclusion, be it for national economy, budget, census, used by corporate houses for business forecast and planning, educational institutions, sports, tourism, etc. Statistics and statistical analysis are integral part of every nation's planning commission and economic growth projections. Statistical analysis is a mechanism which transforms a disorganized, meaningless data into organized, structured, meaningful, and useful data, which can be used effectively in planning and development activities. Frequency distribution helps in transforming the raw data into organized and important data for statistical analysis and inferences. Introduction to statistical methods. Statistical methods are broadly classified under four headings: basics, central tendency and dispersion, regression and correlation, and normal distribution sampling. In the basic stage, the statistical analyst would look into collecting information with respect to the variable information that he needs in the form of data. Data can be calculated in the form of primary or secondary data. These data that has been collected with a specific objective or purpose needs to be arranged and classified for further analysis using various statistical techniques, and that is where we use the technique called frequency distribution to present the data in a very perfect format. The second and the third group, the central tendency and dispersion, regression and correlations, are useful for understanding the nature and growth of the data. This data further, if needed to be analyzed with respect to understanding its characteristics, we will use a technique called normal distribution and sampling. What do you understand by frequency distribution? Frequency distribution is a process of arranging data into sequences and groups or separating them into different parts according to certain chosen common characteristics. It shows us a summarized grouping of data and presents the data in a form that clearly describes a thematic representation of the data based on the selected characteristics. For example, a consumer goods company would like to know the sales performance of a certain product, say TV or refrigerator or washing machine, in a region for the current year. Central government would like to know how different states are performing on the agricultural yield or milk production. An academic institution would like to know the academic performance of their students in various exams. A company would like to know it has performed year on year on parameters like revenue, profitability vis-a-vis its competitors. This way of compressing a data brings more meaning to the data for better interpretation and effective decision making. Steps involved in constructing an FD table First step is arranging the data, which we call as arraying data. From there on, the data points are further condensed. Later on, the next stage we look at is classification. Grouping of the data is followed with the classification of the data. The grouped data can be represented in the form of series representation. In order to make this data more meaningful, it needs to be organized, classified and presented in a more meaningful format. In statistics, we classify the data using statistical series. A series in statistics is defined as things or attributes arranged in some logical manner. Statistical series are classified into individual series and discrete series and continuous series. Let us start with an example. The above table shows marks obtained by 50 students in statistics in their exam. Data in the above form is called raw data. It is a form of data where all the values are shown separately and is called an individual series. A raw data is typically disorganized, of less use and does not give any valuable information since there is no significance, relationship or correlation of the data. Typically, when we think of a marks of a students, we would like to know what is the minimum and maximum marks, how many passed, how many failed, how many got distinction, what is the class average. In order to make this data more meaningful, it needs to be organized, classified and presented in a more meaningful format. Let us see how we can do this. As a first step, let us use a simple mathematical sorting technique to arrange the data in ascending order, where the data is arranged serially starting from a small value to a big value, smallest to the largest. We can also arrange in descending order, where the data is arranged serially from a larger value to a small value. The process of arranging the data in a certain order is called arraying of data. In this example, we have sorted the data in an ascending order. From the sorted data, we can now easily find the lowest and the highest marks and clearly distinguishable. We have now improved the representation of the data. However, the number of data points still remains 50. Is there a way to reduce the number of data points and make the data set compact and more presentable? In the next step, we will learn how to condense the data using a technique called frequency counting. As a second step, we will now rearrange the data to bring out meaningful information from the data. We create a two-column table to represent the data. First column represents all the possible values of the variables, marks in this case. The second column represents a vertical bar called tally bar, that is put against the number value of the variables. We use one vertical bar for every occurrences of the number in the series. For the fifth occurrence of a number, we use a cross mark from right to left on the four vertical bars. See the example of number 42 and 45. The technique of putting a cross tally mark at every fifth repetition of a data helps in counting the number of occurrences of the value in the end. In the absence of a cross tally mark, we will get continuous vertical bars, which can be confusing to count, leading to mistakes in counting, data representation and data analysis. Now, we have achieved the objective of partially condensing the data from 50 data points to 31 data points using a simple tally bar concept. In the third step, we introduce a new column, frequency, in the table called frequency against which variables. This column contains a simple mathematical value of each variable representing how many times each number occurs in the data set. This type of a data representation is called discrete or ungrouped frequency distribution, where marks are called the variables x and the number of students obtaining the marks as frequency f. At times, the identity of the units, students in our example, about whom a particular information is collected, marks in our example, is not relevant, nor is the order in which the observations occur when the first real step of condensation consists in classifying the data into classes by dividing the entire range into suitable number of groups. In the next step, we have used a simple technique to group the marks column into data points in a range, each of interval 5, starting from the lowest value without using any formula. The groups into which the values are classified is called class intervals. 17 to 21 or 22 to 26 is called a class interval. Length of the class interval is called magnitude of classes. 5 is the magnitude of the classes in this example. Class intervals can also be obtained by subtracting the largest and the smallest value of the data and dividing it by the needed magnitude of the class. For example, in the given data, the largest value is 64 and the smallest value is 17. Therefore, the class interval will be for a magnitude of 5. 64 minus 17 is equal to 47, which when divided by 5 is equal to 9.4. Thus, the entire data can be grouped in 10 groups. It can be grouped into magnitude of 10. Then we need to calculate as follows. 64 minus 17 equal to 47 when divided by 10 gives 4.7. Thus, the entire data can be grouped into 5 groups or classes. As you can see, the number of data points has further reduced from 31 to 10 or 5 in the two tables. Groups into which the values of the variables are classified are known as classes or class intervals. The two values specifying the class are called the class limits. The larger value is called the upper class limit, and the smaller value is called the lower class limit. In the above example, for the class interval 17 to 21, the magnitude is equal to 5, the lower class limit is 17, and the upper class limit is equal to 21. Now, we can see a more meaningful distribution of data showing how many students have scored marks in a certain range. It is clear from the table that maximum students, 15 in this case, have scored marks in the range 42 to 46. Such a table is called grouped frequency distribution table. Having arrived at a frequency distribution table, we will now introduce a concept called continuous series, and two most frequently used types of continuous series are inclusive series and exclusive series. In the above table, if you notice, the lower limit of the second group, 22, is different from the upper limit of the previous group, 21. We count the frequency of 21 in the first group. Such a series is called inclusive continuous series. While dealing with a continuous variable, it is not desirable to present the data into a grouped frequency distribution of this type, because this classification does not take into consideration all the possible values, integers and fractions in a specified range. For example, what happens if the marks is 21.5? Does it get counted in the first range or the second range? In such situations, we form a continuous class interval without any gaps in the data series. In the above table, the upper limit of the first group 21 and the lower limit of the second group 21 are same, but frequency counting of upper limit is included in the second group and not the first group. Such a series is called exclusive continuous series. Any value below 21 gets counted in the first group, and any value greater than or equal to 21 gets counted in the second group. Such a series is called exclusive continuous series. You can notice that the frequency distribution pattern changes depending on whether we choose an inclusive or an exclusive series method. We have used graphical representation of the inclusive and exclusive table to have a better representation of the data with class intervals in x-axis and the frequency in y-axis. While observing in the inclusive graph, there is a peak of the data group 42 to 46 with data frequency more than 10, whereas in the exclusive graph, there are two peaks of the data more than 10 points for the range 41 to 45 and 46 to 51. A frequency distribution simply tells us how frequently a particular value of the variable is occurring. However, if we want to know the total number of observations, getting a value less than or more than a particular value of the variable, this frequency table fails to furnish the information as such. This information can be obtained very conveniently from a cumulative frequency distribution table, which is a modification of the given frequency distribution and is obtained on successively adding the frequencies of the values of the variable according to a certain law. The frequencies so obtained are called as cumulative frequencies, abbreviated as CF. The law used are of less than and more than type, giving rise to a less than cumulative frequency distribution and a more than cumulative frequency distribution table. We shall explain the construction of a less than distribution for the same example. The first column consists of the marks range x. The second column consists of the frequency f. And we introduce a third column which shows the less than cumulative frequency for the given sample. As you can see, the cumulative frequency for the first range 17 to 21 is 1, which is obvious since there is only one data point for this range. The CF for the second range 21 to 26 is computed as the frequency for the range 21 to 26 plus the frequency of the previous range 17 to 21. The cumulative frequency for this range less than 26 is 3, since there are 3 values that are less than 26. Proceeding in a similar manner, we can populate the CF for all the ranges until the last range. The resultant CF is shown in a new table with the range values represented as less than x. We shall next explain the construction of a more than distribution for the same example. The first and the second column remains the same as in the less than scenario. The third column will show the CF for more than scenario. In a more than scenario, we start from the highest range, the cumulative frequency for the range 61 to 66 is the same as its frequency. The CF for the range 56 to 61 is the sum of frequencies of this range 5 and the CF of the range 61 to 66, that is 3, which is equal to 8. The CF for the next lower range 51 to 56 is the sum of the CF of the range 56 to 61, 8, and frequency of the range 51 to 56 as 5, which is equal to 13. Proceeding in a similar manner, we can populate the CF for all the ranges. The resultant CF is shown in a new table with the range values represented as more than x. Similarly, we can also obtain a distribution table using logical grouping of the data points depending on what kind of logic is needed for the business use. In the above example, we have used the standard grading system used by the university to rank the students. For example, pass, fail, distinction, first class, second class, third class. Here, we have classified the data range into more logical groups in order to define the status of the exams and the academic class obtained by the students. Here, we use a simple logic for grading the students and classifying them as per the university graduation class or ranking. Marks less than 35 is considered as fail. Marks between 35 and 50 is considered to be third class. Marks between 50 and 59 is considered to be a second class. Marks between 60 and 74 is considered to be a first class. And marks greater than or equal to 75 is distinction. From the above, you can see that only 6% of the candidates have secured first class and none were able to secure distinction. 16% of the students failed, while 84% of the students passed in different classes. We can represent the above data as a pie chart, where each block of the chart represents a certain data point. We have used the percentage distribution of the students for the different ranking categories. So far, we could understand the construction of a frequency distribution table. The benefits that arises out of the construction of a frequency distribution table can be classified as a clarity in understanding the data, concentration of individual values, pattern of tendency of values, reduction in data to be handled, better representation and interpretation of data, comparison between series is possible. To summarize what we have learnt in this session: what is frequency distribution, how to change a raw data to a frequency distribution table, the steps involved in creating a frequency distribution table: arraying, condensing, classifying, grouping, representing, and series representation. The various types of frequency distribution series: inclusive and exclusive distribution series, less than and more than series.